Picture this. It's late September, about 250 miles above Earth. Inside an orbiting space station, a crew has been circling the planet every 90 minutes for month after month on end. No weather, no rain, no wind. Just 16 sunrises and 16 sunsets a day, all of them filtered through windows in a metal maze you can't step outside without a pressure suit. There is no front door, no sidewalk, no quick walk to clear your head. Between you and hard vacuum is a few millimeters of metal, plastic, and faith in the engineers back home. Now imagine sharing that tube with half a dozen other people for 6 months straight. How do you sleep when your bed is bolted to the wall? How do you eat without crumbs drifting into critical electronics? How do you use the bathroom when everything, including you, wants to float? And how do you stay sane when every window shows the entire planet and nowhere to go? In this video, we're going to break down exactly how astronauts eat, sleep, breathe, use the bathroom, stay fit, and stay mentally sharp on long missions in orbit. We'll look at the systems that turn sweat and urine back into drinking water, the unspoken rules that keep international crews from losing it in a space the size of a small house, and the training it takes to earn the right to leave the planet at all. By the end, you'll understand why long-duration spaceflight is one of the most demanding jobs a human can volunteer for, and why the people who do it are in a different category of tough. If you're proud of the men and women who live and work off-planet so the rest of us don't have to, type proud in the comments below. Now let's float into a world most people will never experience. Sleeping in space. Turning a locker into a bedroom. On a submarine, a bunk is basically a coffin with a curtain. In orbit, you don't even get a bed in the way most people picture it. On a modern station, each astronaut gets a small crew quarter about the size of a narrow closet or phone booth. Inside, there's a sleeping bag fixed to the wall, a light, a vent, a laptop, and a few personal items taped or velcroed in place. Any wall can be the floor. You pick one and call it down. To sleep, you slide into the bag and zip it up. There's no mattress, no real pillow unless you strap something down. Your body just hangs in place, held by the bag and a couple of straps so you don't drift into a vent or bash into the wall during the night. Some astronauts let their arms float freely, others tuck them in because waking up to your own hands bumping your face gets old fast. Outside your tiny cabin, the station never really shuts up. Fans run constantly to move air because there's no natural convection in microgravity. If the air didn't circulate, exhaled carbon dioxide would build up around your head like an invisible bubble. Add the hum of pumps, computers, and experiment racks, and you get a kind of mechanical white noise that never goes away. Earplugs and sleep masks become part of your survival kit. The schedule is written to mimic Earth. Most crews wake around 6 in the morning, go off work in the evening, and have a dedicated sleep block on the daily plan. On paper, that's 8 or more hours. In reality, between science, repairs, exercise, messages from home, and just wanting a few quiet minutes to stare out the window at the planet you left behind, many astronauts scrape by on less. The strange part is that once their brains adjust, some people actually like sleeping weightless. No pressure points, no sore shoulders, just you in a floating cocoon, zipped to the wall, with the steady hiss of life support where most people would hear rain. Eating in orbit. When crumbs become a hazard. Feeding more than 100 sailors for 3 months underwater is a logistics flex. Feeding 6 or 7 people on a station that cannot run to the store while everything floats is its own kind of miracle. Space food is not the bland gray cube stereotype anymore. A typical pantry in orbit is built from several categories. Thermostabilized pouches hold things like stews, soups, and scrambled eggs that have been cooked, sealed, and heat-treated. Freeze-dried meals come as lightweight bricks that get hot water injected through a valve, then get eaten with a spoon right out of the pouch. There are irradiated meats like beefsteak in a sealed package. And then there is the holy grail, fresh food. Fresh food means apples, oranges, carrots, sometimes cherry tomatoes, sometimes a bag of tortillas. It rides up on cargo ships and has to be eaten within days before it spoils. Those first meals after a resupply, when you bite into something that crunches, are morale events. Bread almost never shows up because crumbs are a menace. On Earth, they just fall to the plate. In orbit, they drift into eyes, fans, air filters, and circuit boards. That is why tortillas became the default stand-in for bread. They roll, they fold, and they do not explode into floating particles every time you take a bite. A day in orbit still runs on 3 main meals plus snacks. Food is portioned and packaged on the ground months in advance. Each astronaut has their own color-coded packets and a few bonus items they chose themselves. On board, people mix and match, trade, and improvise. Someone will always bring hot sauce, and that bottle instantly becomes the most valuable item in the galley. Hot drinks start as powders in sealed pouches. You hook up a water line, inject the right amount, and drink through a straw. On some missions, astronauts have tested special cups shaped to coax liquid along the walls instead of relying on gravity. Not because it is necessary, but because being able to sip and smell your coffee like a normal person helps when you are months into an unnatural life. Breathing and drinking. Running a mini-planet. Submarines turn seawater into air and fresh water. Space stations have to do something tougher. Run a little artificial planet in a place where there is no outside environment to draw from at all. On a modern station, the environmental control and life support system takes the role of an invisible Earth. It keeps cabin pressure close to sea level. It controls temperature and humidity so sweat does not hang in the air. It provides oxygen. It removes carbon dioxide and trace contaminants that would slowly poison the crew if they build up. Oxygen mostly comes from electrolysis. The station takes water, runs an electric current through it, splits it into hydrogen and oxygen, vents the hydrogen away, and feeds the oxygen back into the cabin. There are backup systems and tanks from different partners, because when it comes to air, redundancy is not a luxury. Water is where things get both impressive and slightly uncomfortable. The water recovery hardware pulls in moisture from cabin air, condensation from equipment, and urine from the toilet system. It distills, filters, and chemically treats all of that until what comes out the other end passes strict drinking standards. Astronauts joke about yesterday's coffee becoming tomorrow's coffee. But that closed loop is exactly what makes long missions possible. It sounds grim if you focus on the source. In practice, by the time the water reaches a drink bag, it is purer than what a lot of people on Earth have at the tap. And every drop that gets recycled is one more drop that did not have to ride a rocket into orbit. If humanity ever wants to live on the moon or make a shot at Mars, this is the foundation. A machine that quietly turns sweat and waste into the next glass of water and the next breath. The space toilet problem. Nothing falls down. You cannot talk about life in space without answering the question everybody really wants to ask. How do astronauts go to the bathroom when everything floats? The answer is air. On station, toilets use airflow instead of gravity. Fans pull air down into a chamber, and the airstream carries waste with it. For urine, there is a hose with a funnel at the end, different shapes for different bodies. For solids, there is a small seat with a built-in vacuum chamber underneath and a narrow target. You use foot restraints or thigh bars so you do not drift, line yourself up, flip the fans on, and hope you have your aim right. Urine gets collected and routed into the water recovery system. After treatment, a good chunk of that ends up back in the drinking supply. Solid waste is dried, compressed, sealed in bags, and packed inside cargo vehicles. When those cargo ships are full, they are undocked, allowed to drop back into the atmosphere, and disintegrate in a streak of fire along with everyone's least favorite part of the job. Newer toilet designs are more compact and more user-friendly than the older models. They still rely on the same basic physics. You keep yourself still, you use suction instead of gravity, and you never forget that a plumbing failure in a sealed station is more than just a bad smell. People laugh about it, astronauts included. But when you are months from home with no way to open a window, the toilet is just as critical to health and morale as any shiny scientific experiment. Hygiene without showers, staying clean in microgravity. There are no showers in orbit. Spray a normal shower head, and you do not get a relaxing stream. You get a cloud of floating droplets hunting for electronics and air intakes. Instead, cleanliness becomes a routine built from workarounds. Astronauts wash up with rinseless body wipes and small packets of water. They wet a cloth, wipe down, and then use another cloth to pick up the extra moisture. There is no standing under a stream of hot water and letting it all run off. Every droplet has to be managed. Hair gets cleaned with no-rinse shampoo. You work it into your scalp, massage it through, and then towel it out. Toothbrushing looks almost normal, but you spit into a cloth or swallow the little bit of foam rather than spraying into a sink that does not exist. Clothes do not go into a washing machine. There is no washing machine. Shirts and socks get worn until they are too gross, then stuffed into trash bags to be burned up with the regular waste. Fresh clothing comes from a storage bag, and opening a new shirt in the middle of a long mission can feel like stepping into a hotel after weeks of camping. It is not glamorous, but just like on a ship underwater, people adapt. Routines get efficient. You learn what really makes you feel human and what you can let go of. 2 hours a day just to stand on Earth again. Weightlessness looks fun in clips. Astronauts flip, spin, float through modules, and toss candies into each other's mouths. The part nobody sees is the physical bill that microgravity starts running the moment you leave Earth. On the ground, your bones and muscles are constantly under load just from standing and walking. In orbit, that load virtually disappears. Your spine elongates. Your leg and back muscles start deconditioning. Your heart does not have to work as hard to pump blood against gravity. Leave it unchecked and you come home with weaker bones, weaker muscles, and a cardiovascular system that is not ready for normal life. That is why long-duration crews are basically full-time gym rats. Around 2 hours every single day are set aside for exercise. Station hardware includes a treadmill bolted to the structure with a harness and bungee cords that pull you down onto the belt, a cycle ergometer that you pedal while floating, and a resistive exercise device that uses vacuum cylinders to mimic heavy weights. Squats, deadlifts, rows, presses, running, cycling, all without a single traditional plate. It is not optional. It is part of the medical plan. Early in the life of the station, even with exercise, astronauts still came back with noticeable bone loss and muscle shrinkage. Training protocols have been refined over time. The workouts are more intense and better targeted now. Some crew members return with similar strength to their pre-flight baseline, but only because they treated exercise like a prescription. Skip leg day in space, and you pay for it the moment Earth's gravity grabs you again. Unwritten rules: surviving a shared tin. You do not pack several adults into a metal tube hundreds of kilometers above the surface and keep them there for months without developing a culture. Space crews have their own unspoken rules, just like submarine sailors do under the ocean. Number 1 is simple: respect the pod. Your sleeping cabin is the only truly private space you get for the entire mission. If the curtain is closed, you knock metaphorically by calling out on the intercom, or you leave the person alone. You do not float inside just to chat. You do not rummage around in someone else's little corner of the station without a very good reason. Noise discipline is a close second. Somebody is almost always on an off shift trying to sleep. That means no shouting down modules. It means securing tools and camera gear so they do not rattle. Music and movies happen on headphones, not speakers. Politics and religion exist, but in carefully measured doses. You are living with an international crew representing different agencies and cultures. A nasty argument is not something you can walk away from. There is nowhere to storm off to where you will not see the same faces again in 5 minutes. Most people learn quickly which topics they can joke about and which they treat with respect and restraint. There are also practical courtesies that become second nature. You wipe up after yourself in the galley. You double-check that food pouches are sealed before you let go of them. You do not leave a cloud of crumbs or a drifting tool for someone else to deal with. You give people quiet time at the window when they clearly need to just stare at their home planet and think. From all that, a different kind of family forms. Crews share meals when schedules line up. They mark each other's national holidays. They go out of their way to make birthdays and big milestones feel special, even if that just means a candle stuck into a dessert packet and a goofy song over the station speaker. When things go wrong, lessons written in fire and metal. Submariners tell stories about floods, fires, and bad valves. Spaceflight has its own list of days the entire industry never forgets. Early capsule fires, decompression events, launch failures, re-entry breakups. Each disaster cost real lives and carved new rules into the checklists and hardware of every mission that followed. Every time people died in a spacecraft, engineers and crews rewrote procedures so that a specific chain of events would never have a chance to repeat. That history hangs over every long mission. Fire in a sealed environment is taken so seriously that every material inside the station is tested for flammability. Oxygen levels are kept within a controlled range to avoid the lightning-fast flashover conditions that killed an entire crew during a ground test decades ago. Air ducts, wiring bundles, experiment racks, even Velcro strips and labels are chosen and installed with burn behavior in mind. Astronauts drill emergencies relentlessly. They practice tracking down the source of smoke. They rehearse sealing off a leaking module. They walk through depressurization checklists until they could do them half asleep. Most of the alerts that actually happen in orbit are minor. A sensor trips. A piece of electronics overheats and smells burnt. A small leak shows up in the cooling system. But the crew's reaction is never casual. They treat each alarm as if it might be the one that matters. In a place where the nearest emergency room is an entire deorbit burn and a risky re-entry away, there is no such thing as "we will wing it." Record stays, pushing human endurance. Single missions of half a year or more on orbit are routine now. Some missions have pushed close to a year in one stretch for a single person, and a few individuals have racked up total time and space that adds up to years of their life. Those numbers exist for a reason. Agencies do not keep people in orbit that long just for bragging rights. Every extra month is another data point on how the human body and mind handle isolation, altered gravity, radiation exposure, and the grind of a highly structured life. Future missions to Mars will mean months just to get there, months on the surface, and months to come home. There will be no quick return option. There will be no live call to a doctor for every decision. The faster we learn where the breaking points are on missions close to home, the better the odds for the crews who eventually leave Earth orbit behind. To people on the ground, those endurance records look like statistics. To the men and women living them, they feel like proof that a human being can stretch their sense of normal far beyond what most of us ever want to test. Who gets to go? Earning your astronaut wings. Submariners earn their dolphins to prove they know every corner of their boat. Astronauts go through their own gauntlet before they ever see a rocket. The basic resume is only the starting line. An advanced degree in a technical field, years of real-world experience, often flight hours in high-performance jets, or work on complex engineering systems. Thousands of people submit applications when a new astronaut class opens. Only a handful get the call. Those select few spend around 2 years as astronaut candidates. They hit the classroom to learn orbital mechanics, space medicine, and the intricate guts of the station and spacecraft. They spend hours in giant pools practicing spacewalks in pressurized suits around submerged mock-ups. They learn to fly in high-performance planes. They sit in simulators while instructors throw failures at them just to see how they react. When you finally become a fully qualified astronaut, you still are not flying yet. You wait for an assignment. Once you are on a specific crew, the training gets even more focused. Hundreds of hours running mission rehearsals. Emergency drills with the exact people you will ride with. Long days in mock-ups, practicing docking, cargo transfers, spacewalk timelines, and contingency after contingency. By the time you strap into a real spacecraft, you have already flown the mission many times in training. You have already survived fires, leaks, and software glitches in simulators. The patch on your arm and the wings on your chest are not decorations. They are shorthand for this. The rest of the crew is willing to stake their lives on your competence. Why it matters. Honoring the people who leave the planet. As we drop back down from orbit and imagine gravity settling back into our bones, one thing should be obvious. Long-duration spaceflight is not a glamorous vacation, and it is not just a background detail in a science fiction movie. The men and women who live for months at a time in orbit give up everything most of us think of as normal. Weather, fresh air, a real shower, gravity, spontaneous time with family. In exchange, they get a window seat on the entire world in a front-row view of how fragile that world really is, from a place where there are no exits and no quick rescues. And yet, they do more than endure. They work. They run experiments that change medicine, material science, and our understanding of climate in the human body. They test the systems that will one day keep crews alive on the moon and on Mars. They are the ones who find the flaws now, so future explorers do not pay the price later. The next time you look up at a clear sky and see nothing but blue, remember that above that blue there might be a small, bright dot racing from horizon to horizon. Inside it are people who traded normal life for months so we could figure out how to survive away from the only home we have ever known. Those are our orbital frontliners, quiet, out of sight, doing a job most of us could never imagine handling for more than a day. If this journey into life in space gave you a new respect for what astronauts actually deal with, the sleeping bags on the wall, the recycled coffee, the 2-hour workouts just to stand on Earth again, hit like, subscribe for more deep dives into astronaut life and space exploration, and tell us in the comments, could you handle 6 months off the planet? Or are you perfectly happy keeping both feet on the ground?